Hi, I remember when I was entered into the ASIC industry, I was thinking that only flip-flops is being used in the modern ASICs. As I have studied a lot about the flip-flop and I was thinking that flip-flop is having far superior than the latches. So I was thinking that latch is no more used in the modern ASICs. Few months later, I realized that latches are being widely used in the modern ASICs. I would say, especially in the high frequency designs, latches are most important elements. So, in the freeze of STA concept, we will discuss various perspective of latches and flip flop. Team VLSI welcomes you in this wonderful session. Please like this video and subscribe our channel. We have a wide variety of video in this channel. If you have not subscribed till now, please subscribe this channel and press the bell icon so that whenever we upload a new video, you will get the notification of that video. So let's begin. So first we will see the logic design. This is the symbolic representation of latches and flip flops. In flip flop, we always use a notch here in the clock pin. So a flip flop and here I am going to discuss about D flip flop and D latch only. It is having a D inputs and two outputs which are inverted to each other. So QB is generally Q bar is invert of Q, and one more input is there apart from the D, that is clock. So in case of flip flop, we use a notch here to represent that the clock pin, right? But in case of latch, we do not use this notch. This latch and flip flop can be represented using the 2:1 mux here, as I have shown here, right? In case of latch, there is one 2:1 mux and the output is feedback to the I naught input here. And in case of latch, there are two mux is used, or we can say that two latches are used here. This configuration is called a latch, right? Or if we talk about the latches in terms of transistor level, we can represent this latch and flip flop using transmission gate. Transmission gate is nothing but a two parallelly connect NMOS and PMOS transistors in this way. So both the transistors here complements each other, means when clock is favorable, both the transistors will turn on together, and clock is not favorable, both will turn off. So let me explain the working of this transmission gate only, then we will easily understand the functionality. So suppose here clock is low, then what will happen? This NMOS is going to off since it is getting low signal, and this here you can see that the signal is clock signal is inverted. So when clock is low, clock bar will be high. So this PMOS is getting in its gate high signal. So this will also in off state. Okay, so transmission gate 1 is completely off, but that moment, since clock is low, this PMOS is getting low at gate and high, this NMOS is getting high at its gate, both this transmission gate zeros, both transistor is going to on. So we can say that this path will be activated, right, and this is disconnected. But when clock is going to high, this NMOS transmission gate, once NMOS is going to on, and at the same time this PMOS is also going to on. So a complete path will be built like this, right? So this path will be activated, and transmission gate 0 will be in off state. So we can say that when clock is signal is 1, D will be transferred to Q, and when clock is 0, whatever output was on Q will retained, right? And in flip flop we use two latches, one is negative latch and one is positive latch. So first latch is called our master latch and second is called slave latch. So output of the master latch is transferred to the slave latch, and clock are inverted between these two. You can realize its function in similar way as I have explained here. And our transmission gate is represented in symbolically in this way. So here dot part is indicating the PMOS and without dot is indicating the NMOS. So this circuit can also be represented in this way, and this complete circuit, which looks a bit complex, can be represented in this way, right? In the next part we will see the function of latches and flip flop. So first we will explain, first we will see the functions of a latch. So we have a clock here which has 50% duty cycle here. First we will discuss about when clock is high. So when clock is high, you can see here this transmission gate is going to on. Why? Because this high clock is going to NMOS, and clock bar is at the same time is low going to PMOS. So this will make turned on. At the same time, here you can see that high clock is going to PMOS and NMOS is getting low clock. So this transmission gate TG0 is going to off. So here you can see that red path, only the red path is activated. So when clock is high, your D input will be transferred to the Q, right? Or we can say that the latch is transparent when clock is high. Now let's see when clock is low. When clock is low, opposite action will be happen, that this transmission gate, that is TG1, is going to off and TG0 is going to on. So what will happen? The output is disconnected from the input D, and whatever value was at the Q will retained. So we can say that when a clock is low, this latch is opaque, means it will not transfer the input to output. It will retain the value whatever previously present at the output or similar thing we can represent table in a tabular form like this. When level is high, latch is transparent and Q is nothing but D inputs, and when level is low, clock level is low, latch is opaque and it retains the previous stage. Now let's see the functionality of a flip-flop. A flip-flop can be represented using these 4 transmission gates: TG1, TG2, TG3 and TG4. So we are going to analyze the we are going to discuss the functions of this flip-flop based on the clock signals. So when clock is low, then see here, this transmission gate 1 is going to be active because the low is going to this PMOS, and similarly TG4, where low signal is going to this PMOS. So TG1 and TG4 is active, whereas TG2 and TG3 is in off state. So we can say that only these red paths are active, and here we can notice that our input D is not going to transfer to Q, but D is being transferred up to this point, and this is forming a loop here. So whatever the previous value was at Q will retain, right? So TG2 and TG3 are off here, and TG1 and TG4 is on, and the path which are activated is like this. Now what will happen when this clock is going to high? So which transmission gate previously active is going to now turn off, and which was the off is going to turn on. So from here we can say that whatever the D inputs was previously sampled at this point is going to transfer to the Q, and no more D inputs is being sampled in this period, right? So when clock is high, our TG2 and TG3 are on, and TG1 and TG4 are off, right? And this path is activated now. So what is going to happen at this clock edge? So in this clock edge, a transition will happen. That means those transmission gates which are on initially is going to off, and which are off is going to on, and definitely it will take some time during this transition, and our output will change only during this transition, because as we have seen in this duration, this path is activated for Q is now Q is retained the previous state, and when clock is high, our D is no more connected. So whatever the value sampled during this period is going to transfer only. So the output will change in case of flip-flop only at this positive edge, right? Let's see through this example. First, let's see the function of a D latch here. So here is a clock signal, and here is a data signal, right? So as we have discussed, for a positive level sensitive D latch, only during the high, only when the clock is high is this latch is going to transparent, and when clock is low the latch is going to opaque, right? So what will be the output? I will discuss only about the Q here. Q bar is nothing but just inversion of the Q. So during these periods, whatever the inputs at D will be transferred to the Q. So you can see here, and in this part, right? And in this period, in these durations, when clock is low, nothing is going to change. Whatever value is at this falling edge will retain. So from this you can observe that this glitch, if there is a glitch in the input during the clock is low, it will not going to affect or it will not going to capture, but the glitches during the clock high is being transferred, right? Let's see for the D flip flop, which is positive here. Positive edge triggered D flip flop is taken. So as I have told that output of this D flip flop will change only at the positive edge. So only at this and this edge, and after that it is going to remain constant. There is no change. So at this moment, at this edge, our D is low, so it will become low and it will remain till the next positive edge. At the next positive edge, D is high, so it is going to high, and it will remain to further next positive edge till here, right? And at this moment, since data is high, so again it will continue high till the next positive edge, and here our data is low, so output will become low and it will continue further on the next positive edge. So again we can see that any glitches either in clock high or clock low will not capture in D flip flop, so its output will be glitch free, right? So let's summarize these things here. So in summary, we can say that the first is transistor count. In case of latch, the transistor count is less. For our example, it is only 10, 2 to 4 for transmission gate, and there are 3 inverters, so 6. So 10 transistors for the circuits we have seen here, only 10 transistors, but in case of flip flops the transistor count is more, it is doubled, so here 20 transistors. Propagation delay, definitely it will be less in case of latch because it is in one stage only, and in flip flop it's in 2 stage. Operation, so latch is operate on the level of clock, whereas flip flop operates on the edge of clock. Types, so latches are generally positive or negative level sensitive latch. Flip flops, we say it's rising or falling or positive or negative, or leading or trailing edge triggered flip flop. Process variation sensitivity, so it's most important things. In case of latch, there are less number of transistors, so it is less prone to process variations, whereas flip flops is more prone to process variation as compared to the latch. Uses as a lockup latch for the hold fixing, we widely use latch, and in high speed ASICs, high frequency ASICs, latch is used. And flip flop, it is most common used registers. It is widely used. With this, I would like to conclude this session here. Thank you for watching this session. Please like this video and subscribe our channel. Our channel is youtube.com/teamvlsi. You can also follow us on our blog, which is having very good articles there on teamvlsi.com, or you can follow us on our Facebook page, Team VLSI. You can also connect to us through our groups, which links are given in the description box. Thank you.